pass you over to Peter Martell, who, as I mentioned, is an electronics engineer, and he's from Network Rail. So
that's a lot, because usually you only do 3. Yeah. They advise about 3.
And he's got a Bachelor of Engineering.
So sorry about that. I'll just come out to my screen, Peter, and then it's all yours.
Okay. Right.
That's it.
Can everybody see that?
Yep.
That's excellent. Make sure we've got the right screen up for me. Bear with me. There we go. Hello, everybody. As the introduction said there, I'm an electrical engineer, but as we'll see in the presentation, there's a lot more to engineering than just the individual discipline that you do. So I'm going to spend a few minutes telling you, first of all, how I became an engineer, and secondly, what I do in my job as an engineer. Just before I start on that, as you heard, I work for Network Rail, and Network Rail runs the railway network. We don't run trains, we allow people to run trains on our network, and you've probably heard of us because you see our signs up at the stations and things, and you may well have heard of us from community engagements where we run safety campaigns. So just at the beginning, I want to remind you that the railway is not a place to play. There are lots of hazards associated with the railways, and you'll see some videos and some demonstrations of things today. And remember that they've been put together carefully by somebody who has got the right approvals to be there. So please don't take anything you see today as any kind of license to go and play and do things on the railway. So serious bit over, let's move on to some stuff about me. What do I do? So I'm Peter Martell. Why am I qualified to talk to you? Well, I went to a university and I got a degree in engineering, which means that from where you are at school, it's a number of years more study. I joined a professional institution and I get to call myself a fellow of that institution. There's an organisation called the Engineering Council that regulates all of the different engineering bodies, and the Engineering Council have decided that I'm good enough chap to be able to put their post-nominals after my name to say that I'm part of that. And I'm also part of an organisation called the Institute of Asset Management, so that we follow best practice in looking after those assets in the industry that we're responsible for on the public's behalf. So how did I get to where I am? Well, it goes back a long way, and some of you may recognise that picture from things that have been in the news recently. It's not that I went to the moon, not that I was anything part of the moon, just that I was born just about the time they were doing that, so that gives you a clue of how ancient I am in this. Like you, I went to a primary school, fairly small primary school, and at the time, maybe like a lot of you, I didn't really have a clue what many things in the world were and what I liked doing. I knew I liked playing, I knew I liked making things, and I knew I liked maths and sciencey things a lot more than some of the other subjects. I then went on to a secondary school, much more grand affair, slightly bigger and a bit more serious because you had to think about exams at the end of it, and I formed more of an opinion about what I liked there. After school, I was encouraged to go to university, but I didn't really have a clue what I wanted to do. And I made a bit of a mistake in my life, which is an illustration here that you can make mistakes and still recover from them. I went to the University of East Anglia to be an accountant. That didn't work out, so I left there fairly quickly, and I went to work on a big cruise ship. I was a photographer on a ship for a year or so, before finally settling down and deciding that I wanted to study electronics. I went off to Kingston University, that's in southwest London. A lot of university degrees let you do your studies and then spend some time in industry. I worked for the BBC for a year in the middle of my degree to learn how to put some of the things I'd learned in the first and second years in practice. And then, that's me some years ago, when I joined what was British Rail. which was when the railways were all one organisation owned by the government. That went through privatisation, that was sold off, and I worked for a commercial organisation called Amy. You may have heard of those, they're still around, they do a lot of work in construction. I moved from there to Network Rail 7 years ago, because when I was working for Amy, I was doing projects for the railway. When I went to Network Rail, I was the customer for those, so I was asking people to do them on my behalf. Since I've been with Network Rail, I've had the opportunity, I've just come back from a secondment in Australia. I spent 2 years there looking at how Australian railways do things and how we can help Australian railways, because the engineering rules are just the same the world around, so it's good to be able to learn from other people's experiences. And I came back to England, and I now work for a bit of Network Rail that's called Digital Railway. And all through this, although I had an interest in the likes of maths and physics and things like that at school, I've realised that most things are all connected together, and that actually some of the other subjects that you might think aren't really connected come together, but we'll see a little bit of that in a minute. First of all, I want to say what an engineer is, and it's supposed to be about engineering, isn't it? But I'm going to talk to you about language first of all, and French in particular, because the French words explain it a bit better. In French, engineer, the person engineer, is this word which I will probably mutilate in my pronunciation of it, ingénieur. There's a word that you may have heard of called ingenious in the English language. It doesn't look that similar to engineer, but in French it's very, very similar. And in fact, if you speak to a language scholar, they'll tell you that the English words do come from the same root back in history. And unfortunately, in English, we tend to think of engineers to do with engines. And if you understand the meaning of the word ingenious, it's about having ideas about things. And the English definition of ingenious is about discovering things, inventing things, being resourceful. And as you can imagine, it's not just mechanical things that you can be resourceful in. And this slide shows you a number of different things that the Engineering Council looks out for, all the different kinds of walks of life that mean that we can come up with solutions to problems across all different things. So you've seen aerospace and technology, and the things like the water industry, building dams, nuclear power, and all that kind of stuff. So engineering is really about asking questions about things, because there's only point in doing something if it's going to have some kind of outcome. So you really need to ask, why do I need to do anything? Now, I don't mean by that, why do I need to get out of bed in the morning? Why do I need to do my homework? They're all important for learning. But there is a reason behind things. You don't do something unless there's an outcome from it. And if you ask the question, why do I need to do my homework? Well, that's because you need to consolidate the learning your teachers have given you. Why do I need to build that wall? Well, it's not because I like laying bricks. It might be, I suppose, if you're in a competition, but it's because you want to separate something or to support something. And that leads on to, well, what's the problem that needs solving? Why is there a problem, and how can I go about solving it? Now, in the railway, as a signal engineer, I've got two main problems. One of the things is that trains take a long time to stop, and I'll explain about that in a minute. And the other thing is that people want to take trains to different places. There's no point in just running a train from London to Bristol and never running trains to anywhere else, because as nice as Bristol may be, not everybody wants to go there. So I'm going to tell you a little bit now about why they're problems for us. So some information about trains. The quick-witted among you will notice that that's not a train. That's a representation of a family car, pretty much maybe like the one you've got, your parents have got or your friends have got. Typically it weighs about 1,500 kilos. Why am I telling you that? Well, that's a representation of a train. That train weighs more like 240,000 kilos. So it's 160 times the weight of a car. And the equivalent of 160 cars in its mass. Also, on the roads, maximum speed that you're allowed to go on British motorways is 70 miles an hour. On the railways, we can run a bit faster, and we run 125 miles an hour. And one of the things with speed, as you may learn in physics or science in some of your lessons, is that if you double the speed of something, then you give it 4 times the amount of energy. I'm not going to explain the maths behind that, but that's something called a square law. So as you double something, the dependent variable goes up by 4 times. So we've got very much heavier trains, and they have got an awful lot more energy because they're travelling a lot faster. Also, the wheels on a train are very different to those on a car. And you've got rubber tyres on a car, and you've got metal wheels on a train. Rubber tyres are designed to give you good friction. Metal wheels on a train are designed to give you very little friction because we want to save energy. And a car will take something like 70 miles an hour. If you look at that bottom line, the red bar there tells you from the highway code, a car takes about 75 meters to come to a stand. That will be in around 3 seconds. That's about the length of a football pitch. Train, on the other hand, would take about 20 times that because it's got a lot more massive, it's got a lot more energy, and it's got less friction. So because of that, we use signals at the line side. And if you want to stop at the red signal, we have to tell the driver where he's going to stop. Because bear in mind, I said it takes the train something in the order of 1,500 meters to come to a stand. So we use a sequence of lights where you come up and get the first caution, which is the 2 yellow ones, and then the yellow and the red. So the distance between signal 2 and signal 4 on the railways is going to be at least 1,500 meters, probably a little bit further. So you can see that things are quite spread out. And this diagram here illustrates how we would try and separate the trains. So the first train at the stop on the left-hand side is stopped, and the signal behind it is stopping, and the other train's going to it. So the train that's coming up is going to come along here, and is going to see the yellow signal, the double yellow signal, and then the red signal. Sorry, the single yellow, and then come to a stand. And as you can see, it moves the light sequence behind it so that another train could come and follow it up behind it. So we keep trains spaced out, and we also need to send trains in different directions. Oops, sorry about that. So at this railway junction, we can send the train that way, and there goes the train through the junction. But we can also move the points, so that represents the train's wheel going on one line, and we can move it so that it goes around the other line instead. You'll see our train, when the points are moved in that direction, will go around the corner. And of course, trains can travel both ways on pieces of line, so you can have a train coming back around the corner, and that crosses over the tracks in the middle and then goes out to where it's going. Now, clearly that set of points we need to know where it is, because if we get that wrong and our train starts to go this way, but then our set of points moves underneath the train, then the rest of the train is going to go the other way, and that's not a very good outcome. And also, we need to make sure that when a set of points is set for a train coming this way, if we've got a set of points that would allow a train to go this way, then we need to make sure that we don't send a train that way, because otherwise we would have a disaster somewhat like this, where we've got 2 trains coming along trying to use the same bit of track, and that is a very, very bad day for everybody concerned. And we've got quite a big railway in England and Scotland and Wales. We've got 65,000 signals. That's an awful lot of signals. We've got 1,000 level crossings. we've got 13 big control centres and lots of little control centres, and it's all spread out over 32,000 kilometres of track. So we've got a few simple problems to solve, and we can solve those with electrical and mechanical engineering. But imagine taking a little machine that you've built to solve a problem in a model and then spreading it over 32,000 kilometres. That's quite a big logistical problem, and that's why we rely on our other engineering colleagues in the railway, where we've got structural engineers to build bridges and hold signals up for us. We've got highway engineers to help us control traffic at level crossings. We've got non-destructive testing people to look at how we can measure things without damaging them. So, a very, very, very quick outline of how I became an engineer and some of the problems that I try and solve, and how we work together with other engineers to get it. So I'm not sure whether that's inspired any questions for you, but Chris, if anybody's got questions for me, I'm quite happy to answer them now.
Okay, so I think we had a few problems with the sound earlier on at the school end, but if anyone does have any questions for Peter, could you, teachers, could you please type them into the chat facility? And then please answer that. It normally Peter will say it normally takes a couple of minutes to, or maybe not that long, but it takes a few seconds to get things underway at that end, and obviously type them in. So you'll see how it goes.
Okay, a question here about how long have I been a railway engineer? I joined British Rail in 1994, so that's just been past 25 years working for the railway. Okay, somebody's saying that they missed the very beginning. Could I recap what an engineer is? And I will try and zip back to that and show you, because what I was saying was that engineering is about solving problems. Bear with me, I'll get back in a second. Okay, so let's just try and reshare this. Okay, so I said at the beginning that the word for engineer is very akin to the word for ingenious. So it's not all about engines and mechanical systems, it's more about ideas. And the English word ingenious means that it's you like discovering and inventing things, and being resourceful and finding solutions to it. And that you can't really start to find solutions for a problem until you know what it is that you need to solve. So you need to ask the question, why do you want one of those? Why do you need to do what you do? And that's why I was talking about problems with trains, or the problem that trains give us, that we have a need to be able to stop trains safely and to separate trains. But the problem is that things are very spread out. And we've got a significant amount of equipment to manage. Okay, somebody else has asked, is my job heavily male and do females get involved? The rail industry as a whole is very male dominated. It is seen as a very physical job with unsocial hours and difficult conditions. As far as the high-level engineering goes, so designers and people solving the problems, there's absolutely no reason why that can't be done by men as well as women. And there are a number of engineers within my company and within the wider industry who are females. There unfortunately are probably not enough, because it's still slanted towards men, but there's absolutely no reason why it can't be done by either. So how old was I when I wanted to be an engineer? I was quite old. It was quite late on when I realised what engineering was and that I wanted to be an engineer. Looking back, I always liked to take things apart and find out how they worked. I always liked to ask, why does something need to be done like that? My mother's lament when I was a child was that the worst word I ever learnt was why, because I would always ask questions and say, well, why does it do that? But it was probably when I first went to university, I went there to study electronics because I didn't know how electrical things worked, and I wanted to understand that. And then I learnt about the wider field of engineering. So another question here, what's my favourite thing about being a railway engineer? I think I like railway engineering because it's a bit specialist, and that's not to say that that just because you do you do engineering, there's a lot of it. So we need bridges, we need motorways, and that kind of thing. But to me, doing run-of-the-mill things doesn't inspire me that much. Railway engineering is quite a specialist subject, and I like doing specialist niche things. I spent quite a lot of time doing work with level crossings, and level crossings is one bit of the railway that you will have seen quite a lot when you're driving along the road, and that's an even more of a specialist bit because that's got extra interfaces with the highways. So I think, yes, I like railway engineering because it's specialist. Am I just solving train problems at the moment? That's a good question, because I said that all things are connected together, and there's a realization in the engineering and management world that engineering solutions aren't the answer to everything. As we make things more automated, we start to make ourselves other problems because the users of the machines don't necessarily understand how they were designed to work, and you then start to get a whole series of other problems. So when we ask about why we're doing something, we should also make sure that we're making sure that we cover what would happen to those people who are going to use it, whether they're the customers of it or whether they're the people who are operating it. Increasingly, engineering is also taking into account how people behave, and indeed how the organisations they work for cope with the automation and the solutions for it. Do I enjoy my job? Yes, I enjoy my job. I can't say that I've always enjoyed bits of my job. There are some times when it gets a bit frustrating when you've dealt with some of the engineering problems, and then you find that the people that have asked you to do that have maybe changed their mind, or you've misunderstood the question. So it can be frustrating sometimes when you think you've done a good job and it doesn't answer the question that the person thought they asked you. Somebody here's asked me if I fix trains, or is the problem solving around trains. So my job as a signal engineer is about the control system that allows the trains to run. So no, I don't actually maintain the trains, but the role that I'm doing at the moment in Network Rail's digital railway program is about moving to a system that allows us to get away from the line side signals. That's one of the significant costs that we've got. Putting thousands of signals along the track side costs a lot of money. So at the moment we're working with the European Rail Agency to put a system on the trains called ERTMS, which is the European Rail Traffic Management System. And that allows us to have a display screen in the cab, which gives the driver the information that he needs to drive the trains. So increasingly, our work is going to be far more involved with the actual train-borne equipment and the drivers, because it's all one system, rather than putting our stuff at the line side and having the driver look out the window for it. What inspired me to be a railway engineer? If I'm entirely frank, I became a railway engineer by accident. I thought that railway engineering was all about bridges and big locomotives and big heavy systems like that. And I'd never ever explored the rail industry. And when I was at university, the organisation encouraged us to go to a recruitment fair, and I saw that British Rail were there, and I ignored their stand because I didn't realise I had an interest in it. And it was only when I got talking to somebody on the stand that I realised that they needed control system engineers. And then I started my career on the rail industry. So when I said about making a mistake and going to be an accountant first of all, and then quitting that, I wasn't really sure what I was going to do, and I was really glad that I found something. Albeit I'd taken some years out and I was a little bit older before I went to university. But when you look back, that hasn't really mattered. I think it's more important to find something that you really enjoy doing than to do something and get stuck in something that you don't enjoy doing. Have I ever introduced or inspired anyone else to be an engineer? It's difficult to answer because I don't keep a track of people I talk to and whether they come into it. I have done several recruitment fairs for people. I've been a mentor in the company to encourage people through their engineering career, and they've developed along the way. I like to share my experiences and to help people understand what it involves. That said, maybe we haven't done our job well enough because we're short of engineers nationally. We're short of engineers in the rail industry, and in fact, we're short of engineers in the world, which is why I had the opportunity to go to Australia. The Australians were looking to us to share our practice with them. How many times do you have to try things before it works? Now, that depends a lot on how well you have designed something in the first place. There's always a temptation, particularly when you're keen to invent something. You have a go and you think, right, okay, well, I'll start cutting this, I'll start bending this, and solder these bits together, and then you find that it doesn't work and you have to go back. There's a principle of sort of sitting down, working out what it's called defining your requirements. That's a very fancy word for saying finding out exactly what it is you want to do. And that's why I emphasised before about the why. Why are we doing this? And now we know why we're doing something, we're going to then work out what we're going to do to solve it. And then we're going to work out how we're going to make that solve the problem. And if you sit down and spend time thinking about how the thing might work, either on paper, on the whiteboard, or discussing it with your friends and colleagues, then it's far easier to discount things that you realise aren't going to work. And once you start making something, that's when it starts costing you lots and lots of money. And there's for each stage that you go through before you find a problem, then it's generally thought to be about 10 times the cost to do it. So if you find that something doesn't work when you're trying to finally test and commission it, then that would be 10 times more expensive than finding that problem just when you've started to build it, which again will be 10 times more expensive than finding that problem while you're still designing it on paper. So some things do slip through the net, and they're more difficult to fix the later on you find the problem. Have I made lots of friends in my job? Yes, I have. I've been fortunate to work around lots of different locations because the railways do cover the whole country. So I get to move around in the UK quite a lot. I've been able to go to Europe and before I spent some time in Australia, but I've also been to a couple of other places where there's railway works to do. And engineers haven't got two heads. They're quite nice people, but there's also lots of other disciplines in the organisation. So there's people who operate the signalling equipment at the control centres. There's people who go and maintain the track. There's people who look after us and make sure that we get paid at the end of the month. So yes, there's lots and lots of good people that I work alongside. A question here about is Brexit going to affect the way we do our job? I mentioned before about us using a system called ERTMS, the European Rail Traffic Management System. And the idea of ERTMS is that a train that starts off in Italy can come up, say, through France and through the Channel Tunnel and still be able to operate in this country. So it's about having the technical and engineering standards to mean that the train works through there. That also has the advantage of putting the equipment in the cab. So even if, with all the discussions that are going on in Parliament at the moment, we leave the European Union from a political point of view, it still makes technical sense to use those standards. And although those standards were developed in Europe, there's actually more bits of railway around the rest of the world that use those technical standards than use them in Europe at the moment. They're in use in China, in Saudi Arabia. The project I was doing in Australia was going to be one of the implementations in Australia. So from an engineering point of view, no, I don't think it will, but from a political perspective, I think things might get slightly more awkward because we deal with quite a lot of European suppliers. Are there any parts of my job I don't enjoy? Yes, I think there are. When I think I picked engineering because electrical components aren't fickle. They either work or they don't. You've designed it right or you haven't. I said about needing to fit in with how people use the system. Users have bad days. Users don't get on with colleagues at work. So whilst I said I have lots of good friends and I like the people there, one of the things I least enjoy is when you've got a situation where you need to convince somebody that you're doing the right thing, or you've done it in the right way, when they have a different agenda to you, and they may be against what you're doing because they don't like something else that was done. So it's when there's politics and disagreements that aren't related to engineering that I find frustrating sometimes. But I think that's probably true of any walk of life. Okay, so what would happen if two trains did hit each other? Well, my little video of the points problem where the train ran into there is illustrative of what might happen. Just like two cars coming together on the road, it's going to depend on how fast the trains are going. There have been some rail crashes across the world and in the UK. Before I joined the railway in 1988, there was a very serious accident at a place called Clapham Junction in South London, and one train ran into the back of another train, which meant that there were carriages all over the other lines, and then another train came through there. And tragically, in that accident, 35 people lost their lives. Now, some years later, there was a train that came off the tracks at a place called Greyrig, and that train was built to very much higher engineering standards and modern crashworthiness. And even though that train came off the tracks at 125 miles an hour and rolled down the embankment, there was not a single window broke on the train. Unfortunately, one person did die in that crash because people were still thrown around inside the carriages. But our rolling stock engineers have done absolutely amazing work over the last years, and you've seen it in the crashworthiness of cars as well, that if an accident is going to happen, it's very much more survivable now than it was in days gone by. So the overall safety of the system is a combination of us as signal engineers trying to prevent crashes, and the rolling stock engineers designing trains so that if there is a problem and if they do crash or come together, then the chances of surviving are much greater. Okay, next one. How long does it take to engineer a train track? I take that to mean how long does it take to build it? From being on the drawing board to implementing it, it will probably take somewhere around 3 to 4 years for a fairly simple bit of line. You may have heard in the news about the high-speed 2 link being built to the north of England, which is taking a very long time and costing a lot of money, mainly because that's going to be a very high-speed line. And if you've got a very high-speed line, then you need to build the tracks straighter and to higher engineering tolerances, because the speeds, the forces are all very much greater. And if you think about being driven in a car, if you're going very slowly, you can go around winding bends and up hills and things. If you're trying to go along at 70 miles an hour, you wouldn't expect to have sharp bends on the motorway. And what's a typical day like in my job? I've told you about lots of the equipment that we do. Typically in my job these days, I don't see a lot of equipment, and I tend to sit in front of a computer talking about how we would manage the requirements that we've got to do engineering things, and to put measures in place so that we make sure that we've got the things right, we've asked the right questions, we've asked the right people if we've asked the right questions, and so on. And so my job, unfortunately, is mainly office-based these days. However, I do get to go out and see bits of railway and see the fruits of our labours when things have been designed as a result of it. And in fact, I'm hope in a couple of weeks' time to be going to a place called Machynlleth in West Wales, because that's one part of the railway that has got ERTMS on there, and some of my colleagues who have not seen that piece of engineering in action want to go and see that. So I will go and go out on the track, and I'll be wearing my orange clothes to see that, so make sure that we're safe out there. Have I ever driven a train? Not exactly in the driving seat of the train. I won a competition some years ago to go to the driver training simulator for the trains that run on the West Coast Main Line, so the Virgin trains out of Euston going up towards Crewe. So they're quite realistic simulators, and they're used to train the drivers to the point where the driver can take control of a proper train. I have been in the front cab of a train, and I have held onto the controls of a train. but I'm not authorised to drive a train. There's a lot of training involved in being a train driver, and even to do it under supervision is very heavily controlled. Does global warming affect my job? Yes, there are certain ways in which global warming and environmental considerations affect my job. The railways are one of the most energy efficient means of transportation. And I said before about the difference between the rubber tyres and the metal wheels on the trains, because on a car or a lorry, about 80% of the energy spent is overcoming the friction on the wheels, and only 20% of the energy spent is done in the actual amount of energy needed to move the thing if you took friction out of it. Whereas on trains, it's more like it's less than 5% is overcoming the friction, and not all of the energy goes into moving the load around. So in signal engineering, we try and make first of all, in the equipment that we actually build, because there's a question here as well as, do we use a lot of plastic? We don't tend to use much plastic in the actual engineering of the products, because they tend to be made of metal, and see the electrical components are metal parts, so metal conductors are metal. So the amount of raw materials that go into the control system is quite low. Where we can help environmental issues is to make things more efficient for the trains moving, and we have a system called the traffic management system, which is about deciding when a train can run and how fast the train can run, and that's separate from the signalling, which signalling is there to prevent conflicts and to separate trains. But if we try and send too many trains down the same line at the same time, then some of them have got to stop. So if we can help the operators to plan how they want to run trains, so that we can keep trains moving at full speed or an optimal speed. Because if you have a heavy freight train that's going along and then it catches up another train and has to put the brakes on, then a lot of that energy is wasted in the heat of the brakes. So if you keep stopping and starting a freight train, it's going to use far more energy than if you can keep it going from its source to its destination. Do I have a uniform? Not in my job. We work in an office that's it's just sort of normal office attire. So I typically wear a shirt and tie to work to try and look smart. The roles that tend to wear uniforms in our industry are those where you've got people who work regularly with the public, and the reason for doing that is so that the travelling public can easily identify people who are there to help them. How many signals have I fixed? Personally, I not that many actually, in true numbers, because I spent time when I was a young engineer on the railway learning about how things worked, and I went out with the maintenance teams, spent a couple of years going around different areas trying to fix things. And then I moved more into the design of signalling systems. So yes, I have been out on the track and I've repaired faults before, but that was only a small part of my job. Have I ever seen trains collide? No, I am really fortunate in the fact that I haven't, because I think that might be quite a traumatic thing to see. Fortunately, the number of trains that actually do come together on the network are very, very small. And even more fortunately, when that tends to happen, it's at slower speed, because we've got so many controls in place to try and separate trains that if several of those controls have failed, then at least they've reduced the speed of the train to reduce the impact of of that collision. And I'm also fortunate in that I have never actually been part of a response team that's had to go and respond to it. I know colleagues who have had to attend crash sites, and it can be quite a disturbing experience when you realise that the amount of damage that's occurred to both to people and to property, and that there's a lot of things to sort out. And what's the longest train I've ever seen? Probably some freight trains in Australia. I was working there near a place called Port Botany. If you were paying attention in history, you may have heard that when the British went to Australia, they went, Captain Cook landed at a place called Botany Bay, and it's just to the south of Sydney. And Port Botany is one of the most important container ports for Australia, and they lots of container ships arriving there these days, and then they go out by road and by rail. And there was a container trains used to come past our office, and they would be 80 or 100 containers long in there. And if you want to see a long passenger train in this country, the longest passenger train I think are the Eurostars that run out of London St Pancras, and they go across to France into Europe. So I think that's the longest passenger train. And we used to move quite a lot of coal around, and that was they were probably about 60 or 80 wagons long. Is my job a 24-hour job? My actual job at the moment isn't, but keeping the railways running is. And in some of the roles that I did earlier in my career, I was responsible for making sure that the assets were working as they should do. And although I didn't actually have to be in the office 24 hours a day, if something happened overnight, then I would get a telephone call to go and try and deal with it. And the closest thing I've ever seen to, we were talking before about have I seen any trains hit each other. I was the engineer responsible for a section of line when one of the sets of wheels of a passenger train came off the rails at a set of points. So I was merrily driving home after visiting my family, and I had a phone call to say that this has happened. So I then had to go to the site to look at the evidence of what was there, to preserve the evidence so that we could investigate what had gone wrong, and then to deal with recovering the damage and getting the train service running. How long do you need to go to university to be an engineer? If you want to become a professionally qualified engineer, I mentioned in the introduction that I'd done a degree, I joined an institution, and then I'd registered with the Engineering Council. The Engineering Council require that your minimum education requirements is what's called a master's degree, and typically a university course to achieve a master's degree will be 4 years. So you'll need to get the sufficient A-level grades to get into university, and then to study for 4 years to get your educational qualifications, and then you have to have experience at the right level. So you start as a junior engineer, and then you've got to gain sufficient evidence that you've been working as an engineer, and that would be typically another 4 years before you could demonstrate that to the Engineering Council. Okay, how long does it take to re-engineer a track when it breaks? Well, if we're talking about the rails on there, the metal that supports the track, sometimes there's defects in there and they break. And there's the need then to take out the piece of rail that's there, to cut the rails to take out that, and then to put in a new bit. And there are two ways that you can join bits of track. You can either still do it as they always did when they first invented railways, which is to bolt a piece of metal between the two bits, a sort of joining plate. It's called a fish plate. Not sure why it's called a fish plate actually, but it's called a fish plate. And that would mean drilling some holes in the rails and bolting them there. That's quite quick. The better way to do it is to weld the two pieces of rail together, so you've got a more solid joint, but that takes longer to do because you've got to set up the welding material, and welding track is quite a spectacular sight to see, because it's almost like a mini fireworks display. The welder sets up a small crucible around the weld, and there's some metallic powder in there, and he applies a sparkler to it that gets it hot enough, and then it produces something that's a bit like lava. It's just a molten metal in the thing, and it flows down and joins the rails together. So that would take a couple of hours to do. So quite often they will bolt the rails together just to get the trains moving, and then overnight, when there's a quieter period, then they will come and weld the track in place. What's the hardest problem I needed to solve? I think probably a problem that we had a few years ago when we had when I worked in Swindon, and we had an intermittent fault with the signalling system. And as the drivers were coming along, they had a green signal in front of them, and suddenly it would go back to red, which is very unnerving for the drivers, because generally speaking, we don't make the signalling more restrictive in front of the driver. We only set the route when the route's available to do it. And we had this problem, but because, as I said, the railway was very spread out, it took us a long time to find out where it was, and the fault wasn't actually anywhere near the signal that we were trying to fix. It was about 6 miles away, because there was a problem with the communication system that was doing it. So it took us several days to do, which was disappointing for the people on the trains, because their trains were disrupted for a couple of days. But, so I got to the end of the questions that are there at the moment. If there's any more, then
perfect timing. I mean, it's 25 past now, and I think we'll close down the meeting unless there's no more. Can I just say, Peter, what a fantastic hour! It's wonderful. Thank you very much. And some very interesting, some great questions from Long Crendon, and some excellent answers as well.
Well, they certainly made me think on some of them.
They did, yeah, yes. They did. So thank you, everybody. We'll close the meeting down now, and thank you all very much for participating. And I'll send you an email, Peter, shortly. And
okay. Thank you.
We'll catch up then. So
thank you very much. Thanks, everybody. Thank you, Long Crendon. Bye-bye.
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 Round of applause.
Thank you.